Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about the nature of nitrogen atom in an ephedrine. That is the point we are discussing. So while discussing this is a very important one, how will you prove the presence of NHCS3 group in an ephedrine? When while answering this, you should mention ephedrine when treated with HR at 300 degrees centigrade produce NH methyl iodide. It clearly indicates that ephedrine contains NHCS3 group. Or how will you prove the presence of secondary amine in the ephedrine? At that moment also you should mention when ephedrine treated with nitrous acid produce N-nitroso compound, whereas ephedrine or similarly when ephedrine treated with methyl iodide consume 2 moles of methyl iodide produce the quaternary ammonium iodide derivative. Clearly these two reactions, by observing these two products, we can prove that, or we can confirm, or we can infer that the ephedrine containing secondary amines. This type of the discussion we already discussed yesterday. What we are going to discuss today? Today we are going to discuss about the nature of oxygen atom. If you observe the molecular formula of ephedrine, you will observe there, you will notice there molecular formula containing oxygen atom as well as nitrogen atom as an heteroatom, and therefore we have learned, we have discussed the nature of the nitrogen atom. Right now we are discussing the nature of oxygen atom. It is very essential. So what type of the functional group it exhibit, so that is the point of discussion we are discussing. Let us see first point we are discussing here about the nature of oxygen atom. See here, ephedrine on benzylation forms a dibenzyl derivative indicating that oxygen atom is present as hydroxyl OH group because one benzyl group is introduced at NH group while the other at OH group, and therefore let us see here C10H, how much is a H15 or not H15, that is a H13 remaining, right? And here if you carry out the reaction with benzoyl chloride as an reagent, so what do you get? Suppose that hydroxy group present in a alcoholic form and another one it may consume with NH like this. As we know that nitrogen is a secondary amine, therefore the nitrogen atom should carry one hydrogen atom, and that's why we have shown like this. And now benzylation, the process is known as a benzylation. Benzylation, it is a process C6H5COCl, benzoyl chloride. benzylation takes place, we are going to get C10H13 as it is, and here the hydroxyl group O, C double bond O, C6H5, isn't it? Now second one, N, that hydrogen atom get replaced by HCl. So here also HCl fumes, here also as HCl, so that you are going to get C double bond O, C6H5, isn't it? So these are the group we are getting over there. These are the derivative we are obtain or we are getting, that clearly indicate that the ephedrine containing as a hydroxyl group. But what type of the hydroxyl group, whether it is primary, secondary or tertiary, it indicate as a secondary alcohol present in the ephedrine. That's the point we will discuss. So second one, B point. Now in the B point, ephedrine on oxidation with K2Cr2O7 in presence of H2SO4 furnish a ketone with same number of carbon atoms. Same number of carbon atom, there is no change in the carbon atom. So we know that the molecular formula of ephedrine is a C10H15NO. So this is the molecular formula of ephedrine, right? Ephedrine, when it treated with Jones reagent, which is K2Cr2O7 in presence of H2SO4. Generally, dilute H2SO4 means 2 normal H2SO4 is employed, and what we know that this is the reagent K2Cr2O7 in presence of dilute H2SO4. It is a reagent or it is an oxidizing reagent which oxidize. So what do you get? H13NO, that is the compound we are getting, and that is in the form of ketone, right? This is the form of ketone. So I think with this, let us stop today here. Remaining we will see in the next lecture. Thank you.